Here we go. Naming things. Yes. That's awkward. I am so glad you guys are here to tell me how to teach, because sometimes I forget. Thank you. That would not have been nice. Can you see my screen now? Is it okay? Does it work? Is it too small? Do you wish I could do it the other way when it was just the tab?
No, that's fine. That's pretty good.
Okay. I am assuming Alex is going to speak for all of you at home. So if anyone objects, you can speak now. Vegas is not here. I don't know. Okay. So I think we're pretty much all ready to go. Everyone at home, I'm sure you've got your notebooks out and you're ready to rock and roll. So let's talk about naming. In computer programming, we often want to name things that we are going to utilize in our programs. The two main things that we will create a name for are things called functions and other things called variables. And whenever you create a function or a variable, you're going to call it something. And here are some guidelines. When you create a new name for something that you're going to use in your program, you always want to make sure that it's descriptive. Don't just call it thing 1 and thing 2. And I know I shouldn't have to say this, but I've got students in this class who would do weird random names like that. They're not helpful, because you want to be able to understand your program and every part of it. If you have a function, which is, again, our next lesson, whenever you're naming something, if it's multiple words, like if you want Tracy to do something else, like draw a flower, don't write out 3 different words. What you would use instead is use an underscore to take the place of a space. So it's like all connected. So you can't have spaces in things in computer programs. So if you want to separate multiple words, you'd use an underscore, which is like the minus sign, but on the bottom of the line. Also in Python, we're only going to be using lowercase letters. And the reason for that is because computer programmers are very, very lazy. They don't want to have to hold the shift key or turn on cap locks to start typing a word and then turning it off. So always use lowercase. It's faster that way. It's more efficient to program with all lowercase letters. And then the last criteria for coding in Python is if you do create a new name of a function or a variable, it cannot start with a number. So you can't put a physical digit. You could write out the number, like with letters, like THREE would be okay for a 3. So when you create a new name of something in Python, make sure that it follows these rules. And we'll look at some examples now. Oh, we're going to go through each of these again. Doot, doot, doot. Hey! So here's the name of a function, which is basically like a new command that we can teach Tracy. That'll be the next part of today's lesson. And I could name the function my_function. Now, let's talk about, is this a good name? First off, did I use an underscore instead of a space? I did. Did I use all lowercase letters? Yep, that's good. Did I start with a number? No, which is also good. But is this descriptive? Does the phrase my function tell you what it's supposed to do in my computer program? No, it doesn't. This is not a descriptive name, so it's not a good function name. So we don't want that. No, no, no. So let's look at these 3 different function names or variable names and decide whether or not we think they are good. So make a dash. Is this a good name to use? There are spaces here. We can't do that. So what do we do to replace a space in Python? We use an underscore. So this is the way you would write out that name. Is make a dash descriptive though?
No.
What? Does it tell you what it's going to do? What does function make a dash do, do you think? I think it makes a dash.
How big of a dash?
Really? I think it's fine. All right, another variable name could be radius, right? Maybe we want a variable to represent the size of a circle with radius. Is radius a good name for a variable? It's descriptive, but what's wrong with the way it's written there? Uppercase, right? We can't use capital letters. We would want this to be a lowercase r to make it a lowercase radius. And finally, 3 circles. Well, 3 circles, that's descriptive, right? That function is going to draw 3 circles. And it's all lowercase, but what don't we like about that? The number in front. We have that number 3. Instead, we would want to write out the word 3, T-H-R-E-E, underscore circles, and that's okay.
Can you start a function with an underscore?
You could, but I don't want you to.
Okay.
In Python, generally starting with an underscore is for something later on that you don't need to worry about. It's for a private variable in an instance of a class, which is way beyond what we're going to be talking about this semester. So don't do that for now. Okay? Okay, that's it. That's it with naming. Good?
Awesome.
All right, all right. I've got applause. How come no one at home is applauding me? I guess. So that's functions. You don't even have any coding challenges for this. Just a little mini quiz to check. Now let's talk more about these functions themselves. What is a function? How does it work? And how do I use it with Tracy the turtle? All right, so I kind of mentioned this before, and this was a program that I showed you last time where you had to put 4 circles on the canvas, like all around the origin. And the way that it was kind of created efficiently is we use this for loop. Remember that for loop was that control structure we learned about last time that allows me to repeat a segment of code. And so for this challenge, to draw these 2 circles, here, let me pull that one up real quick. 2 circles, 4 circles right here, just to give you a better idea of how this program worked. Is I drew these 4 circles here. Wow, that was fast. And to do that, I started by setting my position down here in this bottom left circle. Then I had a for loop run 2 times to draw this first circle, move forward, and draw the second circle and move forward. After I did that, I then, if you look at line 12, I reset Tracy's position right here at -50, 0. Then once I had her go to that position, I could just reuse this same code. Look how this chunk of code is the same as this block of code. Because whether I'm starting down here or right here, the drawing of the 2 circles and moving forward is identical. It's the same chunk of code. And so if I'm going to be repeating code multiple times, a very efficient thing that we can do is to just give it a name that describes what it does, such as a function. And that's kind of the whole purpose of this.
A question.
Yes, sir.
All right, so if it was to be correct in like syntax, would the for loop be in the function or in the start function area?
Let me show you. So first off, a function is basically a new command that we can teach Tracy. Now it's actually just going to be a combination of multiple lines of code that we're going to group together. And we're going to give it a new name, a new descriptive name to explain what it's going to do in our program. And once we create a new function, then if I want to repeat those, I don't know, 5 or 10 lines of code that I put inside this function, instead of retyping those 10 lines over and over, I can just type a single line of code with this more descriptive name. So in that previous example, I kind of just drew 2 circles, right? That's what that for loop did. It had Tracy draw 2 circles. So what if I made a function that I actually called draw 2 circles? Then in my program, I could just set Tracy's position, tell her to draw 2 circles, then set her new position, and then tell her to draw 2 circles again. Then the main part of my program breaks down to being just 4 lines of code. Now I still have to have this new function called draw 2 circles, but it's much more descriptive, it's more efficient, and I can reuse this code over and over again, and I know exactly what it's doing. So these are all these benefits for creating functions. Big thing is it shortens our code and makes it reusable. So if I've got a few lines of code or a whole bunch of lines of code that I'm going to be reusing multiple times, I can put that into a single function that's going to have a new name that I can then tell Tracy to do anytime I want in my program. And she'll execute all those lines of code by just telling her that one command that kind of tells her, hey, go over to this one function up here that I already created previously. So that's the majority of it, is going to be shortening the code and making it reusable. But sometimes, even if you're not going to reuse a chunk of code a bunch of times, we still want to put it into a function just to kind of explain to the user what I'm doing in this program. So it makes it more readable by, if I just have like 20 lines of code, like turn left, forward, set position, forward, turn left, circle. I don't really know what Tracy's doing, but if I put that all into a function called build a pyramid, well now, if I'm looking at your program, I can read, oh, this chunk of code is building a pyramid. And that's where you put all the forward, circle, turn left, set position, or whatever. And that just makes it more readable, which helps you out if you ever need to go back to your program to change something. And it makes it more readable for me or anyone else who's looking at your programs. This right here is how you create a new function. So this is very important. Make sure you've got this written down. If you want to put it in your Python note chart, or if you want to create a special page just for it, because these functions are going to be huge. We're going to be using these every day for the rest of the year. We're going to be creating these new functions. And the way that you create one is you write the word def, D-E-F, which stands for definition, because you are defining or creating a new function, a new command for Tracy. And after that, you leave a space and you write the name of your function where it says function name here. And this is that situation where you want to follow those naming conventions that we spoke about at the beginning of class. So we use underscores instead of spaces. It's all lowercase. It's descriptive. And it doesn't start with a number. Now here's the important part. Look at the right side of that function name. These parentheses, you must have open and close parentheses. And then a semicolon. So this is part of the syntax for a new function. You must have that at the end. Then after this function, you're going to hit a space. And now underneath it is where you're going to list all the commands for what Tracy is going to do whenever you want her to execute that function that you create. Now, the really important part is that it must be indented. Do you remember how with the for loop last week, after you did the for I in range, all the lines of code that you wanted to repeat were always like tabbed over one space? Come on, you remember that, right?
Yeah.
So same thing with functions. Everything that you want to be in the function should be tabbed one grouping to the right, so that when you're looking at the program, it's all grouped together. And Python actually needs that to be tabbed over to know that it belongs inside of that function. So let's look at some examples. Don't call it function my function. So this is that draw circle example we looked at earlier. And since I'm going to have to do this twice, let's put it in a function to make it more usable and to make it more descriptive, to show what I'm actually doing with this for loop. So look at this code right here. I'm going to define a function to do all this code. I write def for definition, draw underscore two underscore circles, open, close parentheses, semicolon. Now, when I hit enter to the next line, the code editor will automatically tab it over to the next line. And since we have a for loop here, that's what's starting it all off, right? There's a for loop. Now, this is kind of interesting because with the for loop, as for I in range 2, semicolon, I'm going to tab over again a second time, because whenever you have a function, you always have to have everything inside of that function tabbed over. But then I have a for loop, and inside of a for loop, I have things also tabbed over. So you've got to make sure that it's all in line with whatever grouping system is right above it. So in this case, these lines of code are all tabbed over. Now, an important thing to note is this line right here, line 12, that says def draw two circles. If I just had this in my program and I ran my program, nothing would happen, because by making this definition, I'm simply telling Tracy, hey, if you ever want to draw two circles in the future, here's how you would do it. You do this for loop twice, circle 50, pen up, forward 100, whatever, do that twice. But if I actually want it to occur, if I'm saying, hey, Tracy, I want you to go ahead and draw those two circles now, I'd have to write this command, just draw two circles. I still have to tell Tracy to do that anywhere in my code. But whenever you've got that word def written in front, that's just creating the definition of it. It's not actually using it yet. It's not commanding Tracy to do this in the program yet. So look right here. That's exactly what I'm doing, Noah. So here is the function definition up at the top, where I'm just defining what to do when I want to draw two circles. Now I can just pick the pen up off the canvas, set a position, and now look at line 19. This is now calling the function, where I'm just telling Tracy, hey, go ahead and draw two circles. When my program gets down to this line, it's going to say, oh, Tracy's supposed to draw two circles. How do I do that? That's not a function that I'm built in knowing what to do. Then she realizes, oh, wait, that's been defined for me earlier up here. And then the program will actually jump up to this line, this for loop, and it will execute all the code that's inside of that function definition. Once Tracy's completed that, then the program will jump back down to line 19 or 20 and continue executing. So it goes to set position at -50, 0. And look at this. We're now calling that draw two circles function again. And Tracy knows, oh, I know how to draw two circles. That code is written right up here for me. And it will jump back up there. It'll execute all the lines of code in that function definition. Once it's done, then it will jump to right after this line 24 if there's any more code to do. So it's a great way to reuse code, to make it more efficient, to make it more readable. Questions?
Does it matter where you put the function?
Yes, it does. Did you read this right here? Look at that. Reminder, functions must be defined before they are called. So what that means is if I'm going to use a function, so down here on line 19, if I'm calling that draw two circles function, make sure that you've defined it, or you've basically given the instructions on what to do with that function name earlier in your code somewhere. So I couldn't have this definition after those, because if I got to this line of draw two circles, Tracy, she wouldn't know what to do. She'd get confused. She's like, I don't know what that means. I haven't learned that yet. So make sure you define the function first. You tell her what to do first. And then later on, you can command her to do that. Any other questions on this function for now? I know it's a weird new concept, but you'll learn to love them for sure.
Do you have another role song?
Yep. All right, so these are your new parts of this lesson. Def, and then the name of your function. This is declaring a function. And then if I ever just write the function name without the word def in front of it, then that's calling the function. So make sure you know the difference between declaring a function and calling a function. Remember, declaring or defining the function means you're basically giving Tracy the steps on what to do. Where calling the function, you're just saying, do this right now. Draw the two circles. That's telling Tracy, oh, I should go and execute all those commands that were typed out to me earlier in the program. So big difference between those two. Any other questions on these? Okay, let me show you some examples real quick. That's not what I wanted. So here's a program example that you can look at that has Tracy drawing these hash marks, like if you're drawing the axes on a coordinate plane. And so first, setting the speed, here's a definition on how to draw the hashed axis. Because isn't this vertical axis, doesn't it look the same as this horizontal axis? The only thing that's different is Tracy's starting position and her starting orientation, whether she's starting facing to the left or starting at the top facing downwards. She's going to be doing the same thing as she moves along a line and draw these little hashes. And so what we can do is create this function called draw hashed axis. Now, if I just write this definition, nothing will happen in my program. I have to actually call that function. And that's what's happening down here. So here's the actual line of code that Tracy would be executing. She's going to pick her pen up and move to this position, 0, 200, which is at the top middle of the screen. Turn right 90, so she's facing south. And then she's going to draw the hashed axis. Okay, so this is where it's descriptive. It tells you what she's doing. She's going to draw one of these hashed axes. And then it knows, oh, I've got to jump up to here where this is defined. Now she's going to run these lines of code. Once she completes these lines of code, those 16 for loops, then it jumps down to the next line. It's going to bring the pen up, go to position -200, 0, which is on the left edge over here. She's going to turn left 90, because remember she was facing down. Now she's going to turn to the left, facing over to the right. And she's going to repeat that same line of code, drawing that hashed axis. So it's going to save you a lot of time, a lot of energy, a lot of code, and it makes your program more readable. If I'm reading these lines of code, I can see what's going on much better than if I had just all of this randomness thrown in there, and I have to kind of analyze it to figure out, well, what's really going on, why is she turning all the time, and this and that, moving forwards and backwards. All right. Last part of today's lesson. Artistic effects. Now, this is where Tracy starts getting really, really fun. Because Tracy, we know she's a turtle, but she's also an artiste. She can paint colors. Yay! This is so exciting. So by default, Tracy is just black, and whenever you draw with her, when the pen is down, she leaves a black line behind her. Well, you've got a brand new command, everybody. This new command is called color. And so this is a command. So in my program, I would just type the word color, parentheses, and then note that the name of the color has to be in quotation marks. All right, if you just write color blue, she won't know what to do, but color quotation blue changes Tracy's color to blue. And then as long as the pen is down when she moves, she'll leave a blue line behind her. And same thing for like drawing circles. She'll draw a blue circle instead as well. So that's your new command. It is so much fun. And she has more than just these two colors, by the way. Look at all this. You don't need to write these all down, but basically any color name you can think of, Tracy can color in that color, which is pretty cool. So you think of a name, you write it, and chances are it'll work. Even midnight blue or cornflower blue or cyan or teal or turquoise. Like these are all just shades of blue, everyone. And there's like 12 of them. Like there's a ton of colors you can pick. Just super awesome. And then just note down here, if you do pick a color that doesn't exist, like, I don't know, milky white of the snow in Canada in the month of January. Like if you type that, I don't know if that's a real color or not. It might be. Crayola makes a lot of colors. It might not actually be a real color built in, and then it would just default to black. So you won't get an error. It just won't actually paint in that color. Here's another command. Pen size changes the size of your pen. It's basically how thick the line is that Tracy will be drawing. So make sure you've got this down in your notebook. That changes the thickness of the trail that Tracy leaves. And so you can see the example down here. If the pen size is 1, it's just going to be a skinny line. But if you make the pen size 10, it's much thicker. This also will help you making fun, pretty creations. It's going to be so good. So excited. So pen size, parentheses, and then a number, just like the speed, where you have various numbers. All right, and for shapes, there's begin fill and end fill. And what that means is these two kind of go in conjunction with one another. If I type the command begin fill, it doesn't matter what color she has, she'll use that color that you previously commanded. And look down here in this yellow arrow at the bottom. This kind of is a good illustration. So begin fill, notice how it has an open and closed parentheses with nothing inside of them. Then I tell Tracy to draw a circle of whichever radius. Well, when she draws that circle, it won't just be the outline, it'll fill it in. That's what we're doing by begin fill. We're beginning to fill this in. At and end fill, it's just everything you command inside there will be filled in. So just be careful. It might draw more on the screen than you're intending if you only want one part of it to be filled in, one little shape. Because you can have her draw like multiple shapes in a row, and she'll fill them all in. And speaking of shapes, we do have more shapes that we can draw than just the circle. That's all we knew so far, but we can get more specific with these shapes. And so now there are some more commands we can give her to draw more advanced circles. So typically when we call the circle function and tell Tracy to draw a circle, we usually just give her one number, and that's for the radius, the size of the circle. That's the distance from the middle to the edge. But if I want, I can put a comma inside that parentheses and write a second number. And this second number is basically how many degrees of that circle do you want Tracy to fill in? Now, by default, this is set to 360, which is one complete time around the circle. But if I put in 180, Tracy will draw only half of a circle. If I type in 90, it'll be 1/4 of a circle. And you can actually put in any number from 0 to 360. Now you probably don't want to do 0 because that won't be anything, and you probably don't want to do 360 because that'll be a whole circle, which you would have got anyways, even if you didn't command it. So circle, radius, comma, extent, comma. Now there's this last part also, another parameter of this circle function called steps. What the steps piece does is it allows you to tell Tracy to include a certain number of stops or points in a circle. This is where we're going to be able to draw different regular geometric shapes. Triangles, squares, pentagon, hexagon, heptagon, octagon, nonagon, decagon, dodecagon. Those are the only ones I know. Sorry. That you want. So if I want Tracy to draw a triangle, I command circle and then parentheses. The 25, remember, is the size of the shape. So this is a radius of 25, which I know doesn't really make sense for a circle. Basically, that'll be the distance from the middle to any vertex, to any of the corners, is 25 pixels. The 360 just tells Tracy to go all the way around the shape, right? Complete the diagram. And then the last number is how many points you want it to have, how many vertices. So if there's a 3, it'll be a 3-sided figure. If there's a 5, it'll be a 5-sided figure. But hey, over here with this last example, there's a 50. Why does this look like a circle? Any ideas? Exactly. So Janina said, well, because if you've got 50 sides on this shape, they're going to be so small that it'll look like a circle for the most part, right? If we zoomed in super far, we might see these 50 edges, but if you try to draw a shape with 50 sides, it's going to look like a circle for the most part. And so you can now make different shapes with different pretty colored patterns and stuff like that. And you can combine all these elements, such as the polygon drawing with the advanced circle commands, along with the color commands to draw whatever you want. And you can fill them in, can make really cool designs. So both of these programs, the examples are in there in the code in CodeHS for you to look at if you want to play around with them and see how they work. Notice this one, there's a red circle followed by a blue square, followed by a yellow triangle, and the yellow triangle is on top. Whenever you're drawing multiple shapes that are filled in with Tracy, she always draws like the furthest one back, like the lowest level one. So she would have drawn the red circle first, and then after that, she would do the blue square would be the next line. And then whatever the most recent line is, that'll be the shape that's on top, the one that you're going to see. So just to make sure you've got all the new commands, here's the final summary list for you. Make sure you've got these down in your notebook because you're going to be using all of them today. And, well, that's it for the lesson. So once you grab out your Chromebooks and start working through these, I want to get you to get through these colors. And if you have any other questions, I'm here to help.
You can watch my music, right?
On your Chromebook is fine, yeah.
Okay.
And let me know. Good luck, everybody.